we are told the curve with the equation y equals 2 ln 8 minus x meets the line y equals x at a single point x equals alpha. Part A is asking us to show that alpha is between 3 and 4. Okay. The first thing we need to do first is come up with some function which represents the point of intersection. Now, at the point of intersection, the x-coordinates and the y-coordinates are the same. So what we can do is we can set the y-coordinates equal to have 2 ln 8 minus x equals x. Okay, so the point of intersection will be where 2 ln 8 minus x equals 0. All we've done is subtracted x from both sides. And I'm just going to let this expression here equal to fx. So we're going to say fx equals 2 ln 8 minus x, like that. Okay, so how do we show that a root to an equation is between two values? Well, first we need to test both of these values and show that they are there is a sign change. So what we need to do is we need to prove, so f3 and f4 have a different sign. Okay, this is fundamentally what we're trying to argue. So let's solve it. We're going to say f3 equals 2 ln 8 minus 3 is 5 minus x, which is minus 3, equals 0.22. Okay, and in brackets here I'm going to write positive. Okay, now on the other side, under it, sorry, I'm going to write f4 equals 2 ln, now 8 minus 4 is 4, minus x is minus 4, which equals minus 1.23, okay, which is negative. And the reason I'm writing this is just so the examiner knows clearly, yep, we know f3 is positive and f4 is negative, so that's good. Now we've got the bulk of our argument done, we just need to finish it with a good concluding statement. So what you need to say on a question like this is you need to say fx changes sign, okay, between 3 and 4. And you also need to say one more key thing, the function is continuous. Okay, continuous. Right, this one is a really important point, and it just means at each point throughout 3, 4, so actually, yeah, throughout 3, 4, each x value leads to a specific y value. Okay. These two conditions mean that there is a root. Okay? So this question is worth 2 marks. Your first mark comes from attempting to find f3 and f4 and getting that fx equals 2 ln 8 minus x. So this part here, and then understanding that you need to look for f3 and f4, all of these contribute towards your first point. Okay. Your next point comes from getting 0.22 minus 1.23 and doing your argument. So stating explicitly that fx changes sign and the function is continuous. Okay. So you need this positive and negative shown, so 0.22 and minus 1.23, and your concluding statement of fx changes sign and is continuous, okay, all to get your next point. Part B is showing us a graph which is labelled figure 2. It says figure 2 shows a graph of y equals 2 ln 8 minus x and the graph of y equals x. It says the student uses the iteration formula xn plus 1 equals 2 ln 8 minus x to the n, where n is a natural number, in an attempt to find an approximation for alpha. This question says, using the graph and starting with x1 equals 4, determine whether or not this iteration formula can be used to find an approximation for alpha, justifying your answer. Well, we are told we need to use a graph or using the graph provided, and we're also told that we need to start with x equal, the first x value is 4. Okay, and now we need to determine whether or not the iteration formula can be used to find an approximation for a, and and we need to justify our answer. So because we need to use a graph, what we can do is we can look at drawing either a staircase or a cobweb diagram. So a staircase diagram, remember, goes something along the lines of this, and a cobweb diagram sort of spirals in like this, like a cobweb does, okay? And the way you determine if a solution exists is if either the staircase or the cobweb converges. And if it converges, then that means the cobweb or the staircase is getting closer to a particular value, and therefore that particular value can be seen as an approximation to the question. The other case is diverges, and if the curve diverges, or if the cobweb or staircase diagram diverges, that means that it's getting further and further away from a specific value, and therefore that method isn't a good way to find an approximation to our answer. So what we can do now is we can look at what we need to draw. So the first thing to do is to draw a vertical line from our x-axis to our curve y equals 2 ln 8 minus x. So let's start by doing that. Okay. The next thing we do is draw a horizontal line from y equals 2 ln 8 minus x to y equals x. Like this, okay? From y equals 2 ln 8 minus x, we draw a vertical curve to y equals x, and then a horizontal curve from y equals 2 ln 8 minus x to y equals x again. And this process just keeps repeating. And let's do a few just to be 100% sure, yep, it converges to where we need it to. Okay. So, as we can see from the curve, it does get closer and closer and closer to a point. So we know that it converges. Now, that's only part of the argument, because remember, we have to justify it. So what we need to say to get our marks for this question is we need to say the iteration formula can be used, okay, to find an approximation for alpha. And we need to word it exactly like this, because saying the words can be used means, yeah, we're answering your question directly, it can be. And by writing find an approximation for alpha, we're using what the examiner has given us, and we're effectively throwing it back at them to say, yeah, we've understood the question and we're doing as you want. And remember, we need to justify our answer. So just drawing the diagram isn't enough, so we can write something along the lines of, because the cobweb spirals inwards for our cobweb diagram. Okay. This way, you've covered all your bases. Okay, you've used your graph, and you're using what you know or what you've learned from that graph to formulate your final justified answer. Okay. This question is also worth 2 marks. The way you get your 2 marks for this question, your first one comes from an annotated cobweb diagram on figure 2, and you need to start at x1 equals 4, and you need to have at least 2 spirals. So if we look here, we have one spiral which goes along here, and we have a second one. Okay, so we know that we have gotten 2 spirals, and that gets us our first mark. Okay then, so we can put a nice little tick next to our curve. The second mark we get comes from our argument, or our justification of our answer. And to get this mark, you need to explicitly state it can be used. Now this one's important in the mark scheme, it's bolded, which means the examiners are looking for it. And also you need to say the cobweb spirals inwards. Okay, so both of these points, all right, like that, will get you your second mark. If you're missing either one of them, you cannot get that second mark. Okay.